So let's read the next problem on page 66 in our student book. It says Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. Mr. Brown also buys a used car. His monthly payment plan is shown in the table. And then it shows how much Mr. Brown pays per month. It shows the month, 0, the first month, the second month, third month, fourth month, fifth, sixth, seventh, and eighth month. Then it shows how much Mr. Brown owes. So in the first month when he buys his car, it costs $2,400. Then in the first month he pays an amount and he owes $2,100 left. Then the second month he pays his amount and now he owes only $1,800. In the third month, he pays his payment plan, and now he only owes $1,500. In the fourth month, he pays his amount. He owes $1,200. In the fifth month, he pays, and he only owes $900 left. In the sixth month, he pays, and he only owes $6,000 left. And in the seventh month, he pays and only owes $300 left. By the eighth month, he does not pay anything else because he paid everything that he owned, therefore he owes $0 a month. The problem asks, find and compare the rate of change and initial value for each function. So what we're going to do is we're going to break down the problem just like we've broken down all the other ones. We're going to ask ourselves what this problem is about. And it's talking about Mrs. White buying a car and Mr. Brown buying a car. Now we have to figure out what we're trying to find out. What is this problem trying to find out? First, there isn't a question, but there are two verbs. It says find and compare the rate of change and initial value of each function. So what we're trying to find is what the initial rate of change is, and we're comparing them for each function. Now we're going to try to find out what information on this table is important. We know that Mrs. White buys her used car for $3,000. That's our initial amount. We know that she makes the monthly payments of $300 until that car is paid for. So that means she's going from $3,000 to $0, and she's paying at $300 per month. And we also know that Mr. Brown initially owes $2,400 a month for his used car and his payment plan. We don't know exactly what the monthly payments are, but it looks like we're going to have to find that out so that we can figure out what the initial value is. We know that the initial values are for both, and now we just got to figure out our rate of change. So Mr. Brown owes $2,400, and then in 1 month he pays for it, and he only owes $2,100. So we're going to have to do some math. Okay? Let's solve our problem. We know that Mrs. White's total bill is $3,000 and that monthly payment is $300. We know the amount owed will continue to decrease by $300. So let's take a look at your table on page 66. Now that we have the table filled out for Mrs. White, and we also have the table for Mr. Brown, we're going to graph it. And when we graph it, we'll be able to visually better compare it to each other. So for each function, as the x value increases and the y value decreases, this is going to show our negative change. So let's make sense of this graph. Our key here says that Mr. Brown is in the red, so he's this red line right here, and Mrs. White is the blue line right here. And what we did was in each table, we just took our coordinates, just like we've been plotting our coordinates in this lesson, and we're plotting it on our graph. So they start off with their initial output at $3,000 for Mrs. White and $2,400 for Mr. Brown. This is their first month they bought this car. They didn't make any payments on it. It's at 0 months. That's our initial output. Then we took the values for Mrs. White's payments and plotted it on this graph. So in month 1, she only owes $2,700. In month 2, she only owes $2,400. In month 3, she only owes $2,100. Month 4, she owes $1,800. Month 5, $1,500. Month 6, $1,200. Month 7, $900. Month 8, $600. Month 9, $300. And month 10, she does not owe anything and she is paid in full. And we did the same thing with Mr. Brown's data points. In month 0, we start off at $2,400. And then month 1, month 2, as he pays, the rate, the amount changes and it lowers. This is what we call a negative trend. He is finished paying. Notice how he finishes paying at 8 months. Mrs. White finishes paying at 10 months. When we graph our tables, this table is graphed here. And Mrs. White's table, Mr. Brown's table, is also graphed here. Notice how it's so much easier to read our graph than it is to look at our table and to write it out. This is why we use graphs to tell what our functions are so that we can compare our functions. So the function for Mr. Brown's payment is here, and the function for Mrs. White's payment is here. The reason why we have a slant going downward instead of the usual ones where we see go upward is because this is a negative function. It's a negative rate of change. The amount owed on the cars decrease as the number of months increase. So these numbers here are high, but the further along the months we go, that number decreases for Mr. Brown, as well as the months changing for Mrs. White. That number, the amount owed, also decreases. So if our graphs trend downward, they start up high and they come down, our amount changes from high to low. This is what we call a negative rate of change. If our graph was the opposite and it started at 0 and it went up with the amount increasing, that means it's a positive rate of change. So a negative rate of change means that the x values increase, and a positive rate of change means the y values increase. Alright, so let's take a look at the next page, page 67 in our student textbook. It says, look at the tables on the previous page. How much does the amount Mr. Brown owes decrease each month? So we're taking a look back at our graph and we're figuring out how much this $3,000, or sorry, for Mr. Brown, this $2,400, $2,400 went to $2,100. We're subtracting $2,400 from $2,100. Our answer is $300. Now let's do the same for Mrs. White. By how much does the amount Mrs. White owes decrease each month? So we start off at our initial output. Our initial value is $3,000. And going from month 0 to 1, Her next data point is at $2,700. So I'm subtracting $3,000 from $2,700. Therefore, I get $300. And Mrs. White and Mrs. Brown each pay $300 a month. Number 8 says, what does your answer to problem 7 tell you about the rates of change for these functions? How does the graph show this? Taking a look at our graph, this shows that they have the same rate of change. The lines match up and they are parallel. They don't intersect with each other. So that means they have the same rate of change, and the lines on the graph appear to be parallel. 9 asks, what is the value for each function? What do the initial values mean in the context of the problem? Our values initially are 2,400 for Mr. Brown and 3,000 for Mrs. White. It says fill in the blanks in number 10 to write an equation for each function where x equals the number of months and y equals the amounts owed. So Mrs. White's plan, her y is how much she owes. It's $3,000. Her initial value is $3,000. How much she paid was $300 for every month. Your x is that number of months. So here's what our functions or our functional equations will look like. Mr. Brown initially spent $2,400. Mrs. White spends $3,000. Each of them spend $300 per month. When I say per, that's my keyword to tell me I'm going to multiply. My x is multiplied into this 300. So every time I make an equation or I make an input, if I put in this function, like let's say the first month, the number 1, the first month that she makes her payment, okay, I'm going to put that 1 where that x is, I'm going to multiply, according to my PEMDAS, 300 times 1, that equals 300, and I'm going to subtract that from 3,000. That's going to give me $2,700 for Mrs. White and how much she owes in month 1. And any number I put in there for the month, it should equal the value on this table. Same goes for Mr. Brown. If I put in a number, if I input my x, I'm going to get y, these values. So these equations help us to determine what numbers these actually are. So what we're doing is we're actually just forming a function to make this graph and ultimately to help us make this table. Number 11 asks, does it take the same to finish paying for the car for both plans? Explain why or why not by describing the rate of change in initial values. And a possible answer could be that the rate of change is the same for both plans, but the initial values are different. It will take more time to pay off for the plan with a greater initial value. In this case, Mrs. White's value is a lot larger. Number 12, it asks, below are 2 companies' rates for textbook rentals. What is the initial value for each function? What is the cost to rent a textbook for 4 months from each company? So we are basically going to solve this problem. A's initial value is $15. Company B has no initial value. We write our problem out to figure out what the final value is for company A, which is $75. We know that company B is $19 per month per textbook, so that gives us $76.